Sample problem 4 reads, consider a car going over a hill. The hill can be modeled as a partial circle. If the radius of the partial circle is 20 meters, how fast must it be traveling to just leave the ground? All right, so in this problem, you are going to assume that the car is going over something that's perfectly round like a circle. And so the radius is 21 meters of that circle. And in reality, the roadway might go like flat and then it goes up over a hill and then it goes back flat again. You're not going to go around the whole circle. But on the top of this hill, it is going at some speed, just fast enough that um, it says the car will just leave the ground. Well, if the car is just leaving the ground, that means that your normal force is going to be 0. Because you don't need the ground pushing up on you to make you go in that circle. All right, so the other thing that I want to mention, because the next problem talks about the apparent weight. When you do apparent weight, that's another word for normal force. And the reason why it's called normal, or the reason why your normal force is called apparent weight, is because if you are a person standing on a bathroom scale, you would look at the number on here and you would say, that's how much I weigh. But it doesn't actually measure your gravitational force. Instead, it's going to measure how hard it's pushing up on you. So if you were to jump up and down on the bathroom scale, the numbers are going to change. But your mass and therefore your gravitational force do not change. So apparent weight is just how much that bathroom scale is pushing up on you compared to your gravitational force. And when your acceleration is 0, your normal force and your gravitational force will be the same. For problem 4, when you go over this circle at the top, your normal force that you need will be smaller than your gravitational force because you're going to be accelerating towards the center of the circle, and the center of the circle is downwards. So in this case, you're going to be accelerating down towards the center of the circle. So when you do the sum of your forces towards the center of the circle, you're going to want to make sure that the center of the circle is down because that's where the center of the circle is. So FG will be positive. And then you go minus Fn because that's away from the center of the circle, and that'll be equal to mass times acceleration to go in a circle. All right, so back to our problem up here for sample problem 4. So to talk about how fast it must be traveling to leave the ground, we're going to do our net force equation. So on this car, the only thing that's acting on it is gravitational force. And there would be a normal force, but because it's accelerating in a circle, this needs to be bigger. The gravitational force needs to be bigger than our normal force. And in this particular problem, we want to not need any normal force. So in this case, the sum of our forces towards the center of the circle, I'm going to say, well, I want to make positive towards the center of the circle. So that's going to just be Fg. And that'll be equal to mass times acceleration to go in a circle, or your radial acceleration. Gravitational force is equal to mg. Then we have mass. The acceleration to go in a circle is v squared over r. And then I just need to plug stuff in. First thing I'm going to notice is that the mass is on the same side in all terms. So I can divide both sides by mass. And these will cancel out. And I'll be left with g is equal to v squared over r. And I'm trying to find how fast. So I'm trying to find my velocity. So I'm going to go ahead and manipulate this equation so that velocity is by itself. So I'm going to multiply both sides by r. That'll get that to cancel out. Then I'll have r times g is equal to v squared. And then to get rid of the squared, I just need to square root. So then I'll be left with the square root of the radius times g is equal to my velocity. So my radius is 21 meters and g is 9.8. Type that into my calculator and I get 14.34 meters per second is my velocity. And that's it.